So in the last lecture, I mentioned that we would be talking about internal and external validity in this lecture. And these are also very important concepts to understand in terms of making an evaluation of how strong the evidence is for a specific conclusion. So the best empirical studies maximize two important types of validity. And again, those types of validity are internal and external validity. And now this is difficult to do because, as you'll see in this lecture, these validities are often in conflict with one another. So as you might have higher internal validity, you're likely to have lower external validity. As you have higher external validity, you're likely to have lower internal validity. So first, some definitions. And so sometimes when we talk about research design, we talk about an independent variable and a dependent variable. And a lot of times the connection between these two variables might be described with words like influences, effects, changes, causes, is a predictor of, is a determinant of, leads to. So as a quick example, cannabis product might be your independent variable, and that cannabis product might lead to, for example, reductions in pain or changes in cognition or changes in mood. And one might say cannabis influences mood, or cannabis changes mood, or cannabis causes a reduction in pain. And so that's how that works. So we just talked about that as an example. So when we talk about internal validity, the definition of internal validity is the extent to which a valid causal statement can be made about the effects of an independent variable on a dependent variable. In our example, the question is, how confident are we that cannabis use causes reductions in pain? And obviously this is an example very relevant for this class, right? When we talk about pain and we want to understand the literature and the studies, how confident can we be that cannabis use causes reduced pain? Causes reduced pain, that is what we're talking about when we talk about internal validity. How confident can we be of that statement? So causal claims require three things. They require covariance. And all that means is that as one variable changes, so does the other variable. So as cannabis use goes up, pain goes down, for example. Or as the temperature goes up, eating ice cream goes up. The other important part here is temporal precedence. So the IV has to happen before the DV, right? So you wouldn't record your pain and then go out and smoke or go out and use cannabis and then somehow decide that cannabis caused a change in your pain, because clearly it couldn't, because it happened after the pain. The IV, in our example, heat or temperature must precede the change in ice cream consumption. Okay, so then what about the third piece here, which is exclusion of alternative explanations? And we talked about that in the last lecture when we talked about confounds. The idea here is, could there be anything else besides the independent variable that could have caused changes in the dependent variable? So if there's something else besides heat and the temperature getting hot, that could cause changes in ice cream consumption. And so an example might be, day of the week, right? So, ice cream always goes up. Ice cream consumption goes up on Fridays. It just happens that Friday was a hot day. That would be an alternative explanation. Okay, so to increase internal validity, what do we have to do? Well, one important piece is actively manipulating the independent variable. You must vary levels of the IV in controllable ways. So if we're interested, for example, in cannabis and pain, we might manipulate cannabis by having some people use CBD only, some people use a one-to-one CBD to THC, and some people use THC only. That would be a manipulation of the IV. Another important part is controlling, or the use of control or comparison conditions, which allows you to see what might have happened under different circumstances. And we covered some of this before in the last lecture as well. So in our cannabis and pain experiment, we might compare cannabis to Advil as a control condition or to a placebo. Another important part of this is randomly assigning participants to levels of the independent variable. Each participant in that scenario where they're randomly assigned has an exactly equal chance of being in any given level of the independent variable. That's called a randomized experiment. And because people are equally likely, based on random chance to be in any given condition, that virtually eliminates the possibility that extraneous variables can influence our results. And why does that work that way? Because any of these extraneous variables will be randomly distributed across the conditions of the independent variable. Okay, so increasing internal validity. Here's an example of how are smiling professors perceived. Let's jump over to that YouTube video real quick here. And apparently we would not be doing that. So you can always Google this YouTube video to take a quick look at that. And while you watch this video, make sure you can identify the IV, the DV, and the ways in which internal validity is strengthened. Okay, now we're going to talk about external validity. What is external validity? The definition of external validity is the degree to which results of a specific study can be generalized to other people, places, times, or ways of implementing the independent variable. Right? This is also known as generalizability due to the results of one study generalized to other people or places or times. And to increase external validity with regard to people, it's important to be explicit about the population from which your sample comes from and to randomly select people from that population. So in our example with cannabis and pain, is the effect of cannabis on pain the same whether it is an edible form of cannabis or inhaled form or topical form? That would be looking at how the effects generalize across different forms of cannabis. Another way to look at it would be, is the effect of cannabis on pain the same for older people as for younger people? So do the effects generalize across the age spectrum? This is a quick figure for showing you how this works. Random sampling is when we randomly pull people from a certain population to be in our study sample. And then random assignment is when they get randomly assigned to be in one group. So for example, maybe the cannabis edible group, or the other group, the cannabis inhalation group, or a control group. And so random sampling increases external validity. Random assignment to condition or level of the IV increases internal validity. So designing a study on cannabis and pain, we're interested in whether edible cannabis products reduce pain. We want to be able to generalize our results to adults with chronic back pain. What would our study look like? So take a minute and think about that. What would our study look like? Here's what it would look like in the context of the figure. We would be selecting from the population of adults with chronic back pain, randomly selecting people to be in our 100 person sample of people with chronic back pain. And then we would basically be randomly assigning these 100 people 50 to an edible cannabis condition and 50 to no cannabis condition, a control condition. And that is how that study would be done, both maximizing external validity and in ways that would maximize internal validity. So there is a dilemma, as I mentioned at the very beginning, about balancing internal and external validity. And so here's some examples. Research with animals versus human participants, right? So do studies with animals or humans maximize internal validity? So for which one of these do we have maximal control over the conditions and variables? Well, of course, it's the animal studies, right? We can control everything, the environment, exactly the dose they get. We can control everything. With humans, it's much harder to establish that level of control. On the other hand, do studies with animals or humans maximize external validity? Well, obviously, going from mice to humans is very hard to do. It's hard to generalize from mice to humans. But if you do your study with humans, it's much easier to generalize from humans to humans. So in the human studies, external validity is much better than animal studies, but internal validity is better in animal studies versus human studies. So animal studies, what makes them ideal for internal validity? Well, again, you have very tight control over the conditions. It means you can rule out alternative explanations. You can clearly randomly assign different animals to different conditions. You have high internal validity. And here you see a rat and basically hotboxing and lots of control over the experience of these animals. Weaknesses, however, unrealistic conditions. For example, in a lot of studies with THC in animals, they may not even be using THC. They may be using an analog of THC. They also may be using high doses, higher doses than what people normally take. And subsequently, or importantly, then they have lower external validity. So human studies, however, are basically, okay, so let's talk about human studies. So the strengths to human studies are realistic conditions, using doses that humans actually consume as opposed to animal studies. What that means is one of the big strengths of human studies is high external validity. Now, weaknesses for human studies, we have less control, less experimental control over alternative explanations, and typically lower internal validity. So that's the trade-off between external and internal validity. So in summary, internal validity is the extent to which a valid causal statement can be made about the effects of one thing on another. For example, how confident are we that cannabis use causes reductions in pain? External validity is the degree to which results of a specific study can be generalized to other people, places, times, or empirical sort of realizations of the independent variable. And this is also known as generalizability. To what extent can we generalize the results of a study? For example, is the effect of cannabis on pain the same whether cannabis is an edible formulation, an inhaled formulation, or a topical formulation? Is the effect of cannabis on pain the same for older people as younger people? Those are examples of external validity.